See, when it comes to this geometry picture, it is not that exactly same like what we have learned in last 15 18 days. Okay, it's completely different. Okay, you are going to apply some logic here. You have to apply some logic here. Understand? So that is not that easy, guys. Seriously, geometry is very very tough. Initially I would say to every person, like, geometry is very easy if you understand the logic, but you have to remember the logic. You have to get the logic first of all. Once you get the logic, the flow, even no one can stop it. You understand? If you get the logic how to, for example, let me draw something, and I would like to know how you're good in logic. Hmm. Let me get my pad. Just me writing pad. Hmm. What's my writing pad? Okay. Okay. Well, let me share this. Any blank document? Okay. For suppose I have I have something, but is this the right? This. Okay. Actually no. How to draw that? Let's say from this, there is a straight line, and there's a curve like this, and there's a one more curve like this, and there are some sort of structural. I'm not able to draw, man. Let me show you the picture. I've seen in a book. Seen in a book. That's a. Um, Let me check. When I search for this, okay, let me show. Let me say something. Bridge. Okay, let's take the same example. Let's very basic example. Can anyone get the logic? How to start the script? I have this. How to start this? Anyone? Guys, if I want to
Get
finish
the
this
point.
bridge, yeah, someone is.
Like
First to
placing
make
the
some,
point.
yeah,
Anyone, one at a time.
first to make columns, then we have then make some semicircular shapes. Uh,
First, we have to make the columns, huh? This,
yeah.
okay. Then,
Then this straight line above
hmm,
that column,
hmm,
then some semicircular arch.
hmm, hmm,
Then we have to connect these.
hmm, hmm. What else? I need a cleaned one, which should be very clear to understand everyone. I'll say one thing. So first thing is where my bridge has started actually from this point in this picture, this point and this point. Correct? Right? So initially I need a 2 points to start this, and I'll connect this. See, we have a 2 points now, and I connected these 2 points. Let me choose any color, green. I'll connect these 2 points and a middle line. Now I want to split this into equal parts. Equal parts. From this to this, I have a equal. I mean, like I have some spacing, and from here to here, I have some spacing. So let's consider for now it's a equal. Okay. Well, it means I have to get this equal points. I have to start one point here, and I have to end one point here, and with a midpoint here. So I need 3 points. I need three different points from this 100% line. So let's consider it's a 15%. Let's consider it's a 15%, and the rest, like we have a 70. So within this 70, so if I split this into the three parts, so this is going to be the 35 midpoint, and this total. Okay, so 35, 35. So this is 35 and this is 35. Let's consider. Okay, well, now this is fun. How to get these points? Using pointed parameter. Pointed parameter. We are going to see now. Okay. So pointed parameter. I have a curve, or else I have a line, and I want to create a point at some parameter values. So this 15, this 31, this 35, this 35, this 15, we generally call it as a parameters. We generally call it as a parameters. Remember, parameter in the sense it's not like a parameter names or anything. Okay, so if you have a number of values, if you have a certain values with a different range, okay, so those numbers we generally call it as a parameters in mathematical geometry, especially. Okay, now I'm done with this. So I have a point and I have a point, I have a point. Now I have to use this point for my families. Like I already have the structural column family, I made it. So I have to place this family. I have to place this family. So I place this, done. Placed it, done. Placed it, I'm done. So where I have one more point here, but I don't want that. I don't want this. So I want to ignore the start point and the end point. We have a node to we have a node to remove the first point and the second point. Okay, we have a node, or else if you don't have, you have to create it. Like drop the items, drop the first item, drop the last item. Okay, so I have a 5 points. I have a 5 points. I drop the first item, I drop the last item. So I have a three more points. So those 3 points I'll be using to place my columns. Okay, whatever. Then if you notice that the first point of this and the second, I mean the third point of this are connected each other. On the other hand side as well is the same. Okay, so this is fine. I created this. Now you have an adaptive component of like the structure of this. You have an adaptive component. If you don't have an adaptive component, you can create the geometry within the dynamo itself. Okay, let's see whatever it is. If it is a rectangular shape, or if it's a square shape, or if it is a like a elliptical shape, whatever it is. Okay, so I already have a family, so I want to convert this family into, I'm sorry, curve into the adaptive component. Okay, I'm done with this. Now I need a one more exactly the same, so I want an offset of this. So when I use an offset of this, so it brings one to another one up to some extent. Okay, well, I'm done with this. Now I need to convert, I want to convert this one to the another shape actually. So you can use this point, and you can use this point, and you have to create a midpoint of this with some sort of a side, and you will be connecting that. So the same thing, like either you can do the same thing here, or else you can simply mirror it. You can mirror it. So I have this and I have this. So the same thing, like I just mirrored. Fine. Now, how do you get this structure now? How do you get this structure? How do you get this structure? Don't look at the complete structure at the same time. First, get all the like vertical lines. Get all the vertical lines. Get all the vertical lines. How did I get that? So I have a curve here. I have one more curve here. Okay, so I have one, no, I have one more curve here. So I need points, equal points. If I have a 10 points here, I need a 10 points on the curved shape also. So this point and this point will be connected, this point will be, and this point will be connected. Now what about these shapes? What about these shapes? So that has a different zigzag system again. So we have some sort of a notes to create to get a zigzag from the points. Okay, so you'll be using those nodes, and you can easily finish it. And what about the railing? So what about the railing? So if you already have some, I mean, if you already have a edge of this side edge and that side edge, you can easily use your general railings. Okay, so I mean, if you see any picture, you have to understand everything in a points, where it needs a point and how to connect the points. Is it point, I mean, are there like a planar points, I mean, like, are they exactly on the same plane, or they do have a different curvatures? So you have to think, and you have to split it based on it for every structure. First, my point, this to point. Okay, I need 2 points. One line structure is done. So convert that into the 5 points, and ignore the first point and last point. So I have a 3 points. So this structure is done. This structure is done. I need this to this. So this structure is also done. So offset, this structure is also done. Connecting this and this with a straight lines, that is also done. So saying is easy. Saying is easy. Playing is very tough, because you have to remember a lot. Okay, so for that sake, what I did, for example, if you're going to play with the points, okay, if you're going to play with the points, I'm gonna share you I'm going to share you all these essential scripts, which are like completely segregated. Completely segregated. If you want to go with the go and play with the points, so check the point possibilities. Okay, how to create a point, like how to create a point from the curves. So everything. Okay, so point. For example, if you're going to play with the lines, open this and check, or else you have an image also here. So you have, but this picture, I think this is an old one. How to? Most of them doesn't have a lines, node names. I'll ask this guy to replace it. Okay. Well, so you have a scripts already, and most of them are like very very easy if you really understand the inputs and the terminology. We have like a 15 to 20 terminologies. That's it, nothing else. Okay, we're going to see that today. And the most important thing is the cow and nubs cow. Cow and nubs cow. I mean, we have a lot of notes when you're playing with the cows. Okay, let's see. Um, where is this?
Rajesh, what is
Hmm.
the difference between curve and nerve curves?
Curve in the sense it have like a 3 points, like a 4 points, 5 points, but they have a the proper plane. They have a proper plane. Okay, nubs curve in the sense they don't have any. I mean, any planers at all. I mean, for example, let's say nubs curve sometimes could be a complex, but curve is always like a simple. Okay, let's consider this. We have a point, and we have a point. This is called a curve, and we have a point, and
Mhm.
we have a point. This is also called a curve. If the line, I mean, generally we calling this as a line, right? But when it comes to the mathematical geometry, we called as a curve. Remember, in mathematical geometry we called as a curve, and it has a single plane. We are going to see that today. What is up? I mean, we can check if there is this plane. I mean, is this curve a planar, like or not? What do you mean by planar or not? For example, we have an x y z. We have a
Mhm.
x, we have y. I'm sorry, we have a z as well on the top. Okay, so if the curve is running on two xy planes, I mean like a x and y plane, so that's called a planar curve. That's called a planar curve. But if the curve has a like this, now this xyz values are different. Here xyz values are different. In this x is 0, x is like 10, and y is 5, and z is 0. And here this is 5 and 10, z is 0. So we have a plane of x and y. We don't have a z here. Correct?
Mhm.
We don't have a z.
Correct.
But if you have a x, y, z values like 5 comma 5 comma 5, let's say 10 comma 10 comma 10, so they are like flowing in a different directions. We're going to see that today, like how to understand the vertical vertexes and everything. Clear? So I'll explain you. So this is line final we played last day. You guys have to set, because like we cannot explain everything. We can't explain everything, guys. Okay, in the entire training session, no, we cannot finish the entire stuff. Okay, so what is this? Okay, still loading. Well, so made it I have used I have created some sort of things for you to understand very clear. Okay, now I just need some answers. What does it create? What it will create? This entire. What I did here. Hmm?
Creating points and
Creating the
making the
points.
list.
Creating the points. Okay. So what's the first point? What's the first point?
It's a okay. 0, 0, 0, 0, 0,
Zero
0,
zero
0.
zero. Okay. 000 is this. And this is going to be the second point, and this is going to be the third point, and this is going to be the fourth point. Now, if you want to see this, right click and show geometry preview. Now I have a 4 points. I have a 4 points. Okay. Now, so I joined all together because like whenever any node it is expecting the points, so you cannot connect a single point to it. So nubs curve dot by points. So this creates a nubs curve. This creates a nubs curve because like we have a see as you said, like we don't have any z here, we don't have a z here, we don't have a z here, we don't have a z here. So is this going to be a NurbsCurve? Is it going to be the NurbsCurve? Okay. Is it like a planar? When I said this, it is saying it's a true because we don't have any z. We don't have any z. We have only two planes at the same time. We have two planes at the same time. So that's why we call it as a planar. And you can check if it has any z value at least 1 or else 0.1. So which is adding a new phase to it, and then that won't going to be a planar at all. Okay. So for example, let's see cow dot by points. I mean nubs cow dot by points. Nubs cow always, I mean, can be a cow also. Don't get confused. Okay, like how a line we just calling as a cow. Even the nubs cow also, like we can call it as a cow. Okay, clear? Nubs in the sense, for example, if I draw something in Revit, so DL, when I connect this, okay, now this is a nubs cow, and when I select this, what do we call these points as? Control points. What do we call this? Control points. Like how many control points we have here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. We have a 4 control points. Okay. You can create a curve with this control points as well, with the general points as well. You're going to see that later. I'll explain you. I'll explain that later. No, we are deviating the concept. Where is my dynamo? Yep. So NurbsCurve, and there is a start point, and if I want to get the start point of it, or if I want to get the end point of it, so curve dot start point, curve dot start point, it returns a start point. Okay, so I'll get the start point of it. So when I hold the control key, if I want to if I want to use the same input for the another node, okay, and if you don't want to use this, hold the shift key, it will be disconnected here. Plane from command. Okay, so when I connect this,
Rajesh, can we
yes,
call control points as vertices, vertex points?
no, they are not a vertex points actually. Control points are different.
Uh,
We have a control points, we have a knots also. Okay, KNOT knot. So that
okay.
terminology is quite different. When you call it as a vertex, for example, you have a you have a cuboid. Let's say you have
Yep.
a cuboid. Okay, you have a cuboid or you have something. So wherever they have a three planes connected each other, generally you have a 2 points, two lines connected, we generally call this a corner point. Correct. So we
Yes.
call it as a corner. But if three planes were connected each other, then we call it as a vertex. Okay, for cows, no, generally not. Mm, even I'm not sure. Don't ask me these. Don't ask me these kind of doubts. Okay. Well, I
No,
think so.
actually,
Mm,
in our modeling, when whatever we're working now, we have 3D polyline, and in that we have vertices, vertex points.
vertex
So
points. Okay.
yeah, so
But
based
for,
on that, I'm asking.
okay. Let's see even now. Let me check. Okay. So I haven't. I mean, see, geometry is a ocean, guys. Seriously, no one knows everything in it. Okay. Well, these terminologies are completely very tough actually. I mean, if you are not from a architecture background, mm, if you not keep using it, no, even okay. Let me check. I think so. Like we can call it, but we'll see if there is a
Okay,
possibility.
okay,
Like if anywhere the kind of a terminology is, then I think so we can use it. Okay, let me.
okay. Yeah.
So curved out start point. So when I connect this and connect this, so it's giving the start point. It's 000. Okay. And when I connect this to this, it's giving me the end point of this. Like 1500. That's a end point of it. Okay. Well, how to NurbsCurve? For example, you have a curve and the input nodes needs a like a NurbsCurve, then you can simply convert a curve to the NurbsCurve. Okay, I mean both are same. They won't change it. There won't be any change in the shape or nothing. Okay, well, still it is expecting a curve, but I connected a NurbsCurve to it. But still it is accepting. So you can call a curve as a NurbsCurve. Clear? But sometimes you cannot call a NurbsCurve as a curve because of the planes. Okay, well, now I'm asking, is the curve closed? Is the curve closed? Okay, let me connect this to this. No, false. So these nodes, I'm just cross checking. I'm just cross checking whether these elements are, is this true? Is this false? Like, I mean, like some sort of a questionnaire. In that case, we generally call this as a query nodes. So cow dot is closed is a query node. Cow dot start point is a query node. Endpoint is a query node. Convert a cow to nubs cow. Is it a query node? Action node. Action which is converting a cow to the nubs cow, so it's some action is getting over there. Okay, so cow is planar. Is the cow planar? I'm just questioning here. True, yes. Nubs cow is the periodic one. Then it's saying false. No, it's not a periodic. What do you mean periodic? We are going to see that later. So cow dot normal. Okay, now I want to give you some hint, like before you play with the geometry. First of all, you should understand the possibilities of it. For example, you have a point. Can you get the vector from the point? You should aware of it. Otherwise, you cannot finish the script at all. You keep struggling to convert this like point to the vectors, line to the vectors. No, everything. You have a planar. Like let's say, where is the PPT? You have a PPT. We have a PPT now. You should understand first. So I have a line. Can I get the vector of it from it? Okay. I have a polygon. Can I create a different set of planes on every edge or in every like vertex points? Okay. I have an arc and I want like I have this arc. Let's consider I have an arc and I want one coordinate system here, and I want one coordinate system here, and I want one coordinate system here. Can I create a coordinate system here? Okay, I have a coordinate system. Can I connect all? Can I connect a? Can I create a curve or an arc based on connecting those coordinate systems? So you have to know the possibilities first. Most of it, most of the iterations can be done like repetitive, like line to vector. So line to plane, line to coordinate system. Okay, polygon to vector. If you have a polygon, you can get the vectors of it. You can get the planes of it. You can create the coordinate system from it. So you should know it. Okay, so that is, I mean, if you're like, at least you don't need to play with those. At least you should aware of there is a possibility that we can get it. Okay, well, so cow dot normal. When I connect a cow, so when I connect this cow to this, it is getting me the vector in which direction, which is actually I mean, like, which is running, which is created. Okay, so cow dot vector and what is the length of it and everything. We're going to see this in detail. Now, let me, whatever we are done, let me phrase this. These are very basic things. Let me, I'm not explaining you all this entire notes, okay, because it kill a lot of time. Now see, this curved coordinate system at parameter. We have some sort of a notes. Curved coordinate system at parameter. I have a curve and I connected the same curve. I'm using the same curve. So remember the same. Okay. So I have a curve, and what is the parameter? So what is the parameter? When I disconnect this parameter, which is creating the points, curve dot coordinate system at parameter. I mean, which is creating the points. Which is creating the points. Totally, it has 11 points now using the range node, range process. 0 is going to be my start one, and 1 is going to be the end. In between, I needed like a values with a step of 0.1. Okay, so when I connect this, so wherever there is a point, it has created one coordinate system over there. From that coordinate system, I need one more point has to be placed. So press Control I. So these are the points where like coordinate systems were created, and I want to create a one more set of points with the x spacing of 1. So when I click on this, see, from that coordinate system, from that coordinate system I need one with a distance of 1. For example, if I want to change it, see how it's keep changing, okay. Now, but up to some extent. Now, if the value doesn't match exactly, you cannot create any, I mean, what did here? So I want to create a surface. You know that there is a possibility and you can play with it, but it should accept your inputs. So where like where you'll be failing like sometimes, okay? So you have to set the limits up to some extent. For example, if I want to see the output up to 6.8 or else like 6.9, 7.2, no. So 6.8, up to 6.8 is working. So set the maximum value to the 6.8. Set the maximum value to the 6.8 and with a step of 0.1 or 0.05, whatever it is. Okay. So you will not face any issues while you're playing with a when I keep changing this. So if it is a maximum value 6.8, yeah, that's fine. So you can see this because like you have to know it at every extent. Some at some point of an extent, the geometry definitely fails. So know that point, know that extent point, and set the value in the number slider. Remember this. This is a most like important when you're playing with any like parametric modeling structures. Okay, like when you're playing with a no, I want this has to be up to 7.5 because my road width is a 7.5. My road width is a 7.5 like meter. Okay, well, then how do I split that? Then if you can't control here, you have to control the start point, the start curve. So you should have to convert this start curve, increase the start curve. So I'll be changing the values here. If I change the values here, it will expand. So it will expand the value. It will extend the values here as well. Okay, clear. Well, point out by Cartesian coordinates. Point by Cartesian coordinates. What do you mean by Cartesian coordinates? I know point out by coordinates. Point out by coordinates. I know point out by coordinates. What do you mean by I know this? What is this Cartesian coordinate system? Instead of XYZ, I need a one more. That's called coordinate system, and it is my coordinate system. I can connect the coordinate systems to it. So from that coordinate system, it has to place the X value, Y value, and the Z values. X values and Y values and the Z values. Okay. Well, for example, I want, let me copy this. For example, if I place any, if I need a coordinate system, I will need a coordinate system here. So coordinate system, autodesk.designscript.geometry dot coordinate system by origin. Okay, whatever. Default, it is considering it's a by origin. Where is a by origin point? This is going to be the by origin point. If I start placing any point here, number slider. So when I connect this to this creates a point from this point. No, don't read from here. I want to read from here, or else I want to read from here. Then what to do? I want to create a coordinate system over there. So coordinate system, let's say point dot by coordinates, again one more. Okay, and I want to set the value like 5 something. 5, connect this to this and connect this to this. Now I have a point here. So when I connect this point to this, now it's creating the coordinate system. Like what is this? It's a point. Now it is expecting the coordinate system. So I have already have a node here. Coordinate system. Now you'll be facing an issue. Coordinate system. Coordinate system with I have any origin values here. I have any origin values here by XYZ coordinate system dot um, coordinate system dot by XYZ. This is expecting coordinate system by origin where we have an XYZ values. By origin XYZ. By XYZ. So this is going to be this, and this is going to be this, this is going to be this. Now I have a coordinate system. Now I have a coordinate system, and I have to connect this coordinate system to this. Now I created a coordinate system now. If I start asking to place a point, now it will be placing the point as per this coordinate system. So this is my new one. For example, if I have a number of coordinate systems and I want to place the point, related to that, then this is what exactly the same. I have a number of coordinate systems. I have a number of coordinate systems on x-axis. On every x-axis, I want at 3.2. I want the point at 3.2, and I want to connect all the points, NurbsCurve dot by points, and now surface dot by loft. To create a surface, it need a cross sections. We are going to play with the surfaces today. So that's what. So when I connect this NurbsCurve and the previous curve, the first curve is the first curve, and this is a second curve, the new curve which we created now. Then I connected these two, and it created some surface here. Created some surface
Rajesh,
here. Yep.
by this Cartesian coordinates, we're using this known, right?
Hmm.
What if we have an angle, or how can we rotate by coordinates in case a project has been in some other location and I just want to rotate it? So I get, for example, if I get inputs from the Civil 3D file
Hmm.
and I just want to move to the Revit coordinates, so can we sort it out with
Move the
angles
rotate.
or angle of rotations?
Move the coordinates means.
If suppose a Civil 3D coordinates is in some other position and my Revit coordinates is in some base point is in a location, so I just want to move those geometries into the Revit location. So can I move using angles if it has an angle or rotation?
Yes, you can. You can change it. For example, I have an XY plane here. Let's consider generally what happens. These coordinate systems are placed. Were placed by the what do you say exactly? The curve points. The curve points. Okay. No, whatever it is, wherever there is a new point placed, it should be on the same coordinate system. Correct? Now
Yes.
whatever you are asking exactly, at this point, this x should not be like this. It should be the same as like this coordinate system. Correct?
Yeah.
Correct? Now we have that. Generally, that's not called a coordinate system. That is called. Let me show you. Let me show you that we have a mm, horizontal frame. horizontal frame rate parameter. Horizontal frame rate parameter. If I start showing you this preview, if you see this, they've created it same curve actually. If you notice it, do you understand, Dinesh? Let me turn off this Cartesian coordinate system. If I hide all this, let me check. Now the coordinate systems are accordingly to the curve. To the curve.
Okay.
Okay, from this curve, I want to get the points exactly. So, I mean, based on your priority, either you can use this. No, if you are using a civil 3D and the points will keep changing accordingly. No, it should not change from whatever. Like I have 100 points. All the 100 points should be based on my rivet coordinate system only. Correct. In that case,
Okay.
you will be using this horizontal frame rate parameter. It will always follow the same rivet coordinate system. You understand? So if you have 1,000
Okay.
points, it will exactly maintain the same. So this always would be the y, this always would be the x, this always would be the z. Clear? So when you
Okay.
playing with any meshes or when you playing with any SketchUp models, if it has a lot of curves, this is the problem most of the architects like placing. I mean, they're facing it.
Rajesh,
Hmm.
actually, what I'm asking is, if I want to move these points
Hmm.
to a location with a rotation, how can I? For example, I want to move these points to a location which is far from here, and I want to rotate it. I'm asking how to do that.
Oh, okay. Wait, you have to wait then. Like, we have a concept called like transformation and translations. Okay. Wait till that concept. Okay. So we have a geometry dot translate. We have a geometry dot translate. You can move this, or else you have a topo. For example, I think topo will. I'll explain it today. So we have these points. Okay, and we have a surface. We have a surface which is like a topo surface. Okay, these coordinates points exactly to be placed on those topo surface. Do you understand? If you want to move this, if you want to move the same coordinate systems to a extent with with the x value or y value or z value, or else no, it should on a like a different thing, on a different curvatures or like a different surface. You can use it. You just wait for some time, Dinesh. I'll explain you.
Uh,
Okay.
okay,
I
Rajesh.
think
Actually, that
mostly
this Cartesian coordinates will get the point value from 0, 0, 0 to the which point we give as input, right?
exactly.
Okay. Fine.
Okay. Well, so there are a lot of nodes that we can that you supposed to play with. Okay. So pointed by coordinate system, by Cartesian coordinates, NurbsCurve dot by points. Okay, and curve dot trim by end parameter. What do you mean by this? What do you mean by this? Let me I think. Mm, hide all geometry preview. Yes. Hmm. Cartesian coordinate system. I want to turn off this preview also. So I have a curve. So I have a curve here. Curve dot points at chord length from point. Okay. So when I connect this, so it has created some sort of a points. Okay. And curve dot split by points. I already have a curve. I already have a curve, but I want to convert these curves. I mean, I have to split these curves. Split the curve into the points. So what do you need? I need a curve and I need a points to split it. I need a points to split it. So I have the curve here. So I already connected the curve here and I have a set of points. I have a set of points and when I connected the points to it and I can see a number of curves now. So what are these curves actually? So when I click on this first curve, so 0, So 0 to 1, it's a first curve, this to this, second curve, this to this, third curve, fourth, fifth, sixth, seventh, eighth, 9, 10. Total, we have a 19 curves. Okay, so if I want to check the curve length, it's 1.00725 something. So there are total, how many? 20 different curves. 20 different curves. Okay, well, I have a, I mean, for example, um, I have a curve of this, and this is going to be the path. So this is how actually it creates. I already splitted this into the number of points here. So I have a number of curves. So I have splitted that. I have one single curve and I splitted that into the number of points. And I have connected that. I mean, I just created a like circle. I just created a circle here. I mean, if you want me to show, right click and show all geometry preview. So curve dot planet parameter. I already have a curves. I already have a curves and I have created a circle at every plane. Created circle at every plane, and now I just converted that into the solids. It could be anything. It could be anything. You can do like a lot of things as well. Now I don't want this. I need a space between. I need a space between the every end of the curve. So the start, that is fine. If you want to play something, I need a space between these two. 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 In that case, try to understand, this is a cow. This is one cow. I'm sorry, this is one cow. And I don't want this entire cow. I want to leave some space. I want to leave some space up to this extent. So this is going to be the space. And here again, this is going to be the space. And again, this is going to be the space. How to do that? So I have a curve. I have to end some value. I have to trim some value. I mean, I have to trim the curve. I have to trim the curve. That is what I did. Erase all the drawings. Control B. So what I have done, curve trim by parameter. So just trim that here. I mean, if you want to see, if I extend this, if I see the value, let me, I think because of that, curve, and that's a path. Now it's changing. Now you can see, if I start decreasing it, see now, it's adding the space. So there is a gap between like 0.1, 0.1, now 0.2, 0.3, 0.4, 0.5. This is how. This actually it looks like. No, I don't want to trim at the end. I want to trim from the start. Trim dot, I mean like curve dot trim by end parameter and curve dot trim by start parameter. Okay. So if you want to get the curve length, once it is trimmed, you can see the length here. Curve dot length. Okay. Well, so this is a one of example, and by center point radius. So let me turn this off. Okay, so what is this? I have a curves. Yep. So I have got a start point, circle dot by plane radius, circle by center point radius normal. What if I connect this to the circle to the profiles? This looks something different. this looks something different, and there is no proper shape next to it. There is no proper shape next to it. If you notice it, that's because of this node. Circle dot by center point radius and normal. Normal. So I can change the vector. So here it is expecting, try to understand, in every node there is an input. By I have a center point, I need a radius, and I need a direction. I need a direction. So center point and radius, normal in the sense we generally call as a direction. Okay. So that is a direction. Direction means in which axis it has to be. No. If it this has to be like a z axis. No, there is no circle. I mean, it cannot create. Let me change this to the x axis. This is how actually this gives an another structure. This gives an another structure for you. See, the initial, the start circle is not the right one actually. Second, third, fourth, okay, five, six. Again, when it comes to the end, no, it's not exactly the same for everyone, for everything. Okay, so let's say control B. Circle by plane radius. Always when you are playing with any curves, you must have to get the planes first. You must have to get the planes first. Okay, so to get the plane, how we have a curved pointed parameter? Curved pointed parameter. Okay, try to understand. Now I have a curve. I have a curve. So I need a points. So pointed parameter. Pointed parameter. So this plane is completely opposite to the another plane. This plane is not exactly the same as this plane. So there are a lot of difference in the planes as well. Then you have to get the planes also. You should get the planes as well. Then plane at parameter. Plane at parameter. Then it will place the plane accordingly. It will place the plane accordingly. Okay. Then curved plane at parameter, and then you have to connect the plane to the plane and change connect the radius to it. So circle will be placed on the exact plane with the given radius. No, if the radius is not exactly the same. So here it is like a start with 0.3 and the radius it should end with a 0.8. Then you have to check how many items you do have. Like you have 20 items, and you have to set the value 0.3 double dot 0.8 0.8 with step off. I needed 20. I needed 20. Now it returns total 20. There is all the drawings. So when I circle, and if I want to see, now it started with it started with zero point 0.3 and it ended with a 0.8. You understand the radius. Okay, if I say 21, see, still it returns 20 items because shortest lacing. What if I change this lacing to the longest lacing? It returns the 21 item also, but that is irregular shape. That's irregular. I don't want that. So change this lacing to the shortest. Here, if you notice it. So this is how it would be. Okay, well, play with all these options. What else we have here? Curve dot trim by start parameter. I have already shown you this. Circle by center point radius. So if you have, if you want to create a circle by center point, you have to connect the center point to it, and it needs a radius. Curve dot extruded solid. What is this? What does this do? So that is considered the center point as a origin point, the default point, and it has like created one um, uh, like one circle, and that circle is extruded as a solid. We have some other nodes also here. Extrude as solid. Maybe that's another one. Well, so circle by center point radius and curve dot extrude as solid. And if you have a curve and you can connect that, you can play with an offsets as well. Let me set all this together. Ideal geometry preview. Curve dot offset. If you already have a curve, it creates an offset to it. Let's say right click and show all geometry preview. It's giving you a warning. What is that? I connected the same curve. I connected the same curve. I connected the same curve to this. And what it is saying, the offset wire is degenerate. So it is not, I mean, it's not properly like creating an offset. In that case, if offset fails, then we have a node called geometry to translate. So what do you need exactly? The same curve, okay, and the translate. So what do you mean by translate? So how do you exactly translate it? X translation, Y translation, and Z translation. Okay. So what do you mean by X translation? Let's say use slider. I'll use a slider, number slider, and when I connect this to this, so it creates one more. Let me set it to the Z. You can see on the top of it. Okay. Okay, fine. This is fine. So even for the same coordinate systems like what you were expecting, you have to connect the coordinate systems to it. You understand? Dinesh, the same node, we are going to play with this later on with your coordinate system. You have a number of coordinate systems. Okay, and that
Okay.
coordinate systems has to be connected here. And now you will be exporting, I mean, like you will be importing, like how to import the XYZ points into the Dynamo, correct? So, for example,
Yeah.
you have an X value, you have a Y, I mean, you have an X columns, your Y columns, and you have a Z columns in the Civil 3D. You have a points here. So extract these points and connect to the point dot by coordinates. Point dot by coordinates. Now you will be getting like a X, Y, and Z. So connect all the X
Okay.
values to this and Y values to this and Z values to this. Get the points. Get the points. Okay. So it will create a number of points. That points can be converted or else directly connect the X translations to this, Y translations to this, or Z translations to this. So the same coordinate system that you have seen on one plane, it would be different planes. We are going to see this later. Clear? We're going to see this later.
Okay. An-
Okay.
Anyway, we are going to use the geometry to translate node, right?
We are using it. We are using it. Not only we have a lot of these kind of a nodes. Okay. Don't worry. So geometry to translate. Now I have this curve and I have the basic curve. Now if I want to convert, I want to convert this into the curve, I mean into the surface. So surface dot by surface dot by
Rajesh,
yes, Dinesh.
actually, you said it will offset, right?
Huh.
In case if I want to offset in the XY plane, how can I offset it? Is there a trick or
Yeah,
something like
you
that
will
for
be
XY
connecting the
translation?
same this to this. You have to
No,
connect.
for exact offset.
Exact offset
Uh,
means
in the sense, I just want to offset either in the right or left side with the curve, complete curve. So either if I give either X translation, it will create it in the X axis.
hmm. If
If
you
it is in
connect
Y,
this to the
it,
x axis, then it will be x axis. Now, if you want to get the x and
yeah.
y, then x is this and y is this. You understand? So y is this.
Okay.
Let me show you. Let me show you. List dot create. List dot create. This is going to be the one, and this is going to be okay. The same one. Hold the control key and this. Now I have two curves here. So when I connect this to this, it's a cross section. No, I don't want this. So x, y, and z. Now see, earlier it was only the z direction, and you can see the top. But if you have a different plane, like including the z, including the z, I have a x also. Then what I do, I'll connect this x to this. See,
Not is it only x and y points?
not only,
Only x and y. We don't want z
yeah, x and y.
in case. Give the same value to the phi and phi. Maybe we'll try giving phi as value.
Okay.
So it is not exactly the offset, right? It is somewhat moving from the plane. What I'm asking is, I need the offset of the curve which we has given as input. So how we should give the x and y?
Understood.
That is my
Understood. Wait for we have a session called planes and vectors. I don't want to confuse you. We have a planes and vectors concept. I mean, in the next session, we are going to play with the planes and we are going to play with the vectors, where you come to know everything in detail. We have, I mean, even you can use that here as well. I'll show you that now here itself. Pull onto the plane. Pull onto the plane. I already have a curve. And I want to convert that into, I have to connect that into the particular plane. So how do you get the plane? So you will be getting x, y, z, and let me show you. I already have curve now. Let me remove this. Okay, let me remove this. Now I already have a curve and I have a plane. Let me check where is the plane here. Show all geometry preview. I have a plane somewhere. Control B. I have a plane somewhere here. On this plane, I want to create a curve. I want to duplicate this curve. So curve pull onto plane. It's not called offset. It's something different. Okay, show geometry preview. Now I can see exactly on the top of it. On the same plane, XY plane. For example, if you change it, X and Z. Now it is an X and Z. No, if it is an X and Y, you can see the same plane with this particular distance. That's called curve pull onto plane. Like this, we have a few more nodes as well. Just
can
this
you
is
can you zoom, Rajesh?
Mhm.
Zoom. No, not in the geometry part.
Okay.
Okay.
They're exactly
Okay.
placed
It is
on.
in the same place, right?
It's on the same place because you are using the same vertex. You have to just wait. Who is this? Dinesh, right? Dinesh,
Yeah.
I can't explain you in the mid of it because to start explain the plane, I have to come from the beginning. So that is somewhat confused. Okay. Well, just wait for some time. I'll explain you. Okay, the planes.
Okay.
That one, what you are asking for. Okay. Well, where we are? Where we are? It's where we are.
Translation. Geometry translation. Yes.
Geometry translation. Where is the node?
Curve dot
Deleted
pull,
Yeah,
the.
pull
here.
on to plane.
Curve dot offset. Curve dot offset. Okay, curve dot offset. It is alternative to this. Here, the geometry dot translate. Okay, so geometry dot translate, and this is the one. For example, now if you want to convert this into, if I want to change this curve, if I want to change this curve, position from one plane to the another plane, you will be using mostly will be using like a geometry dot translate. Okay, geometry dot translate, and we have a geometry dot rotate. We have a some sort of a nodes again. We'll see that later. Okay, now I have this cross section. We generally in geometry, if you want to play with these kind of a curves and everything, we have two different terminologies. One is closed, one is semi-closed. So this one we generally call it as a cross sections. This one we called as a cross sections. Okay, to play with the cross sections, that would be a different strategy. And if you play with the circles, I mean the closed loops, we will be using like a different one. Now, I think I have already explained you this. I have two cross sections now. This is cross section, right? Is it a closed one? Is it a closed one? No. Correct? Guys?
It is not.
That's not closed now. This
Yes.
that is also not closed. If I want to create a surface from this, then how do you create? How do you create a surface from this? Then use a list dot create and surface dot by. We have a loft. We have a loft and surface dot by patch. Surface dot by patch. We have these two. This, if you have any closed loop, then you have to play with this surface dot by patch. If you have any like cross sections, they're not closed. Okay, then you cannot connect one. For example, the one which I created, I have a cross section here. When I connect this one cross section to this, it gives an error. It needs minimum one, minimum two. So cross sections it is expecting. Closed, no, it's not closed curves, it's a closed curve. One is even fine with this. When if it is expecting two cross sections, when I connect this to this, it creates a surface. It creates a surface. But when it comes to the closed curve, it needs a curve. Like for example, circle. Circle by center point radius. I have a circle and I can simply connect this to this. If I connect this to this, it gives an error. So circle and cross sections. Cross sections. Okay, fine. What if I have a rectangle? I have a rectangle. Rectangle by width, length, whatever. There is a default. Oh, it is expecting plane as well. Rectangle dot by width, length. So it has already created a default one and it is a closed one, right? It's a closed one, correct? So when I connect this to this, it creates a surface. It creates a surface. Let's say fine. When I connect this, it creates a surface. If I connect the radius to this, and if I connect the circle to the closed curve, it creates a surface. Okay, so I have a surface. Now if I want to extend the surface, how? If I want to extend the surface, surface dot thickness, surface dot thickness, surface dot thickness, surface dot thickness. Well, when I connect this to this, okay, so where is my line here? So this is a circle and it is adding the thickness on the top and the bottom. The top and the bottom. Clear? So surface is a thickness. For example, if I change the thickness to 2, now what is happening? When I connect this to this, so it is this and this. Select this. Select this. Now this is a center point and this is a circle like center and it is expanding one on the bottom and one on the top. Clear? Clear? Guys, you clear? So while you're playing with the surfaces, you have to remember one thing. So surface dot by loft, surface dot by patch. Okay, well, now I've seen this. No, if you want, no, I just don't want this, the thickness on the both sides. Then we have one more node that is called surface dot thicken. And when I connect this, the same surface to this, And thickness, I would say, but I don't want it on both sides. Boolean. I don't want it on both sides. Connect this. Now it's on a top. No, I just want, I mean, generally I'm playing with a columns. It has to be in the down. So it's the negative value. Negative value. So surface dot thicken. Okay. So I have a surface dot by loft here. I have a surface. Let's consider something, anything else. Let's consider this a surface and I want to play with this. I want to play with the surface. I want to play with the surface. How do I play with the surface? I have this as a cross section and this is a one more cross section here. Okay, fine. So I have a surface now and get isolate. Get isolate. What do you mean by get isolate? Understand the ISO directions now. Understand the ISO directions now. So when I connect the surface to this, when I connect the surface to this, and ISO direction is in italic and parameter also it is in italic. So the default value is 0. The default value is 0. Why there is a 0, 0? What if I change it to the 1? Read the description over there. If direction double equal to 0, creates a U parameter line. U in the sense X line. X line. Okay. And if V direction, that is something else. It's like a vertical. Okay. Now that's a different one. Now what if I change this direction to 0 to 1? I can see a line this side. If it is 0, okay, I can see this line this side. Clear? Okay, now fine, this is fine. But what is this parameter here? What is a parameter? That is edge. Which edge? This is a direction and this is which edge actually do you want? No, I want this like a 0. I mean, it's a 1, right? Now let me check. When I connect this to this, oh, this is on the other side. When I connect the 0 to this is on this side. Okay, well, if I want to get the midline of it, then what to do? I don't want this start. I don't want this start and I don't want this end. I want to get the midline of this. Then how to do that?
0.5.
Exactly. So I'll be setting this value to the 0.5. 0.5. Select this. When I connect this to this, see, it's exactly at 0.5 now. No, I want to get this like into the 3 parts. I mean into the 5 parts. 5 parts, and the first has to be ignored and the last has to be ignored. Then range 0. It should start with a 0. I mean, I need this and I need this, or else I want to start at 0.2 and I want to end at the 0.8. Let me show you 0 double dot 1 double dot 0.2 with the 5 separations. Okay, well, I say not 0.2. I don't know. I need a 5 numbers actually. So 0 with 5. Now it's 0, 0.25, 0.5, 0.75. Okay, now 0.2 is not the main. I'll go with a 0.25. Okay, with a step of 0.75, with a step of 0.25, with a step of 0.25. So it created 3. I got only the 3. So the first and the last were eliminated completely. Okay, well, I just want to play with, I want to keep the same. I want to play with this, and I already have some sort of an adaptive component here. I just want to connect it. Okay, well, I just want to convert this into the famless, or else we'll see something. Now, in which direction actually I want to create some circle here. Okay, well, we'll do that later. So surface.getIsolen. Okay, I'm done. So I got the surfaces. I want to get the vertical also. Then what to do? Same copy, paste. Again copy paste. Then I'll change the direction to the 1. Okay. I'll say control I. Okay, I don't want to see this. Just give me a second. I don't want to see. Hmm. Okay. Now I can see this. Now I can see the equal separations on the mid. Okay, it is creating a three different curves. So three different curves, and it's creating three different curves. Okay, fine. Well, now this is on other hand side. No, I don't want to play with that for now. Control I have these three, and I want to place the points. I mean, I want to place the circles, the three circles, and I want to convert that into the sweep. How to do that? Can anyone explain how to do that? How to do that? I want to place one circle
First,
here
we need to get the point of the end line,
in line. So curve dot end,
curve dot end.
curve dot end point. Okay, we got the endpoints. Yep, we got the endpoints. Okay, very good. Then
We need to create a circle.
circle. Which one? We have a number of options. Center point radius, by center point radius normal, by plane radius, by 3 points, by best fit through points. These are query nodes. So which one I want to go with?
I think the second one by center point radius and normal.
By center point radius normal. Okay, fine. So center points are this. Okay, okay, but they are in a different direction. No, they're in a different plane. But I want this plane actually. I want to exactly place on this plane. So radius. Okay, let's say 0 slider. I'll use a slider. 0 with a step of something. Okay, that's fine. But what about the normal now? What about the normal now? Try to do the same thing again. We already played few minutes back. Okay, and I want to do the same again. Then
One.
what is a normal? Normal is a vector. Don't think about the vector for now. So we'll play with the vectors in the next session. Okay. So vector dot by coordinates by 2 points. We do have any vectors? How to place a vector? Vector dot by coordinates x y z. Okay. So when I connect this to this, no. Well, I'll set this value to 1 and connect the z. No, it is not z. Oh, is this the same? Correct? Is this the same? If I change this to the x, no. What about this? Can we use the x also? No, we can't use
No.
the x. So we can use y here. Correct? Well, this is fine, but I have a circles now. I have circles and I have a path. So what do you do? Sweep. Sweep. Use sweep. Profile, it creates a solid. I want to create a solid. Solid by sweep. Yep, sweep a solid. Well, the path is going to be the, circle is going to be the curve and path is going to be this. Now see? Now see? Is it done? It's done? Clear?
Yeah.
Okay, well, sure. Fine, let me check with slider. Let me reduce it. If I increase it, this is fine. Now let's see one more example. Like how do you exactly play with circle dot circle dot by plane radius. by plane radius. So you need a planes now. How do you get the plane? Very important. You keep playing with these two again and again and again. Frequently use notes when you're playing with the geometry. Circle by plane radius. How to get the planes now? Radius is fine. Plane is how to get the planes now. So I have an endpoint. I have a curve. How to get the planes now? And that should be shape should be completely same. So how I have like a surface to get isolate. Okay. So plane at parameter. Remember this point at parameter and plane at parameter. So curve this fine. This is fine. And what about the planes? Parameters when I connect this to this, it has exactly created the planes. If you notice it, the were planes were created. Correct? Correct? Well, fine then. When I connect the planes to this and radius, I've set 0.3 something. Let me set 0.3 to connect this. Okay, 0.3. Curve sweep as solid, Control C, Control V. When I connect the circle to the curve and path is same, is it giving exactly the same? This and this. Are they giving exactly same?
No.
Why? They are somewhat different. Okay. If I just want to see like what is happening here. Okay. So solid dot difference. Solid dot difference all. So solid dot union when I connect these solids and when I connect these solids, okay, well, so when I connect this solid and when I connect this solid each other, I can see the difference. I don't want to see this hide all geometry preview. Now if you want to see the difference, do you see the difference here? There is a change in the starting. There is a change in the starting and there is a change in the end again. If I chain this solid from here to here and I chain this here to here, if there is any change here, no, that is same. That is same. Only there is a difference in the start and end. Clear? For example, if you need a flat surface, or else you have to start from the flat surface through the curve. Then that should be different. You have to play in a different case. So keep changing, and whenever you tried this, instantly you have to try this. Okay, instantly you have to try this as well. Clear? Well, so what else we have? Circle dot by center point radius by width length surface dot again. Pointed parameter, plane at parameter, coordinate system by plane, horizontal frame. Remember this when you're playing with the coordinate system anyhow. I'll explain this later. This also I'll explain later. Radius normal, coordinate system and length, curve dot length, tangent parameter. If you have any curves, and if you want to get the vector, if you want to get the vector, so this is the node that you should play with, like plane at parameter, like how many we have. Let's point at parameter, point at parameter, point at parameter. Okay, hit enter. Plane at parameter. Likewise, tangent at parameter. If you have a curve, you can convert that into the points. You can get the points from it. You can get the planes from it. This one you can get the planes from it, you can get the vectors from it, and you can get the points from it. Clear? Remember these three. Remember these three. You keep playing this again and again and again. What is this curve dot extrude? What is this curve dot extrude? If you have a curve, for example, we just played here something, we just played here with two different cross sections. We have two different cross sections. Let's say delete, I don't have anything here. I don't have anything. I just have a simple one single, where is the curve? I have one single curve. Okay, no, I think, where is the curve here? Okay, I'll use this curve. Okay, so I have a single curve and I want to get this. Where are all these three? Curve dot extrude. Curve dot extrude. So this extrusion will convert this into a surface. If you say this is a surface. I mean the curve itself, which is extending, like direction. And here this is saying it's a distance. And the same curve dot extrude, it's giving the direction. And no, the curve dot extrude, which needs a direction and the distance as well. So if you want to play with the direction and the distance together, then you have to use a curve dot extrude. Both of these three nodes names are same, but the use cases are different. Okay, remember this. Well, curve dot start parameter and curve dot end parameter. No, if I want to show you the same curve, connect this to this, and if I change this show all geometry preview, so that is a direction, z axis. And what about I don't want this. There is a default distance in this. If I want to change the distance, I don't have a control, then I'll be using this. So curve to this, and the direction same, and the distance let's say 10. That's it. Let's say 4. Let's say 4. So that's it. Now I can connect this curve into this wherever it needs a surface. So I connected the surface to it. So it creates again the same. Well, what else? There are most of the nodes are very easy to understand. It's not that tough to remember. Okay. Well, we have some sort of a notes that you guys play with it. Okay, I'm gonna share you. These are not regular, like we have already played with parametric point. Curve dot reverse. So if I want to get the reverse directions, the curve dot reverse, curve dot split point. Let me show you a few others as well. Poly curve, NurbsCurve. Only for curve you do have a lot of nodes, guys. But compared to the other, no, we don't have. We have a very less. NurbsCurve dot degree. I mean, it's a query node. Is the NurbsCurve rational? Is the NurbsCurve is periodic? NurbsCurve control points. If you connect any NurbsCurve to it, it will get the control points of it. From that from that curve, like control points. Let's see. You can create a one more curve. Let me show you. Oh yeah, I already have this. Select model element. Select model element. Select model element. I selected this, and element dot curves. Element dot curves. Element dot curves. When I connect this, I have a curve now. So I have one single curve, and this is a NurbsCurve. So NurbsCurve dot control points. NurbsCurve dot control points. It's giving me the control points. Actually, they are not the same points. They are the different points. And now what to do? I'll be using this NurbsCurve dot by points. When I connect this to points to this, yep. See, this is giving me the different NurbsCurve, and this gives a different NurbsCurve. Clear? So this is a different one, and this is a different one. Clear? NurbsCurve using the control points. Well, NurbsCurve by points. It's the same. What is this difference? NurbsCurve did by points, NurbsCurve, we have a closed curve as well. I mean, do you want me to close the curve? If I say Boolean, yeah, I want to close the curve. Now, it gives something like this. It gives something like this. I think one of you asked me the same, like how to create a Dubai Infinity Tower. Who is that? Is that you or someone else? Dubai Infinity Bridge. Do you say this? To get this logic, the same, okay, which is exactly the same like this. Okay, but we'll be placed that this infinity like was placed with a like how many points? 1 2 3 4 5 control points, but this bridge needs total 11 points. It seems 1 2 3 4. I struggled a lot to get this actually. 14 points. 14 points to get this. Okay, here we used only xy, but we'll be using xyz as well, z also. Okay, well, that's a different story. So NurbsCurve rational is periodic with the degrees knots. We'll see this later. We don't use the knots at all. We don't use the weights at all. By control points, by control point tangents also. So by control point tangents, tangent means like if you have any line, if you have any some set of lines of another curve, you have to get the start tangent and you have to get the end tangent of it, the curve. Then you have to connect the points to it. Then it will create a NurbsCurve. Try playing with all these nodes. Okay, NurbsCurve control. That's it. Mostly we'll be playing with these nodes only initially. Okay, let me close this. I don't want to save this. Let me play with arc. We have 20 minutes. Let me finish all the basic stuff. Arc dot by best fit through points. Arc dot by through 3 points. If you have a 3 points, like connected, it will create an arc. If you have the 3 points, like start point and end point with the tangent in the sense again a vector. If you know the vector, then it will create the arc in that direction itself. Okay, well, you have a points, and if you want to connect a best fit through the points, then arc dot by best fit through points. Like we have a circle dot best by like curve dot by best fit through points, like we have a few, and arc dot by fillet. So what do you mean by arc dot by fillet? We have one line here and we have one line here, and if you want to get the fillet, so this radius you have to assign. So this is, you have to connect this curve and you have to connect this curve to this curve too. Okay, and the radius you have to set like 0.5 or 1 or 2, whatever the radius you have to set. Then it will create a fillet. Arc dot by fillet tangent to curve. Okay, so you need a curve 1 and you need a curve 2, and in which direction that you want. We will be like using this when it comes to the MEP elements. For MEP elements, we do use this. So arc dot by center point, sweep angle. So start end tangents is the same thing actually. Start point, center point, and end point. Center point, start point, and end point. So center point, radius, and angle. Play with all this. Rectangles. See, we have very few nodes. This is a frequently used node. This is a very frequently used node. Rectangle by width and length. So by connecting a width and length, it will expand. Okay, you can control with this. Now, not only width and length, I know the coordinate system as well. I would know the coordinate system as well. Like, how do you come to know? Let me write that. Is it the arrays? For this dynamic simulation, I think no, I haven't used this. No, I haven't used this. Not this one. Which one is that? Okay, we'll see. Rectangle, right? So it needs a coordinate system. So if you have any coordinate system, at that coordinate system exactly it will place. It will create the rectangles. Okay. Now if you know the planes, like how we have created like circle by plane radius. For circle, it need a plane and need a radius. Here, it needs a plane and not the radius, width and length. Width and length. So instead of the circle, you can see the rectangle solid profiles, sweeps. Okay, rectangle by corner points. These corner points, if you want to connect, the corner point should be exactly the same. Like let's say, Control B, Control B. If you want to create a point, like if you want to create a rectangle, so the first rectangle should be, the point should be this, and this point should be here, and third point should be here, and fourth point should be here. So you have to connect all these together. If you connected a point, like let's not create, and you connected the second point of this, and third point of this, and fourth point of this, then it will try to create like this, and this is not a rectangle. So it gives a warning. If you want to use a rectangle dot by corner points, so it should be in a either clockwise direction or an anti-clockwise direction. Remember this. Okay, well, that's it. What about the circles? Circle by center point radius, you know this. If you give the center point and the radius, it will create the circle. Circle by 3 points. Now, for example, I have a circle. So this point, I know this point, and I know this point. This point is on XY. This point is on YZ. This point is on XYZ. Now, is that going to be a circle? Huh? Is that going to be a circle? Let's see.
No.
Erase all the drawings. You can let me show you. What is it? Point 1. So point dot by coordinates. Point dot by coordinates. And I have one more point. Control C, Control V, and I'll Control B. I can drag this, and I placed in the point somewhere, and I connect this to this, and I have one more point. Control B. Control B. Let me connect this to this. So it has created a circle. But it is keep changing the planes. Okay, keep changing the planes. Whatever. Let me change the values. Let me change the values. Wherever you see. What are the values that you keep change? It's always a circle. Generally, when you understand the logic, the one the previously said, it will not be the circle. Okay, but here it is clearly saying that I want a circle by 3 points. I don't have an issue with any planes or anything else. If based on the points, I want to create the circle. That's it. Clear? Well, circle by center point radius normal. So center point, if the center point is going to be this and the radius something like this, and normal in which direction? Vector. Again, you need a vector. So you can connect any vector, planes or whatever to this. So circle by plane radius, we already played with this. We already, yep, you if you have any points, let's start create. Connect this to this, connect this to this, and connect this to this, and connect this points to this. Is it returning exactly the same? Same? Both are same, right? This one and this one. Both are same. Okay, if I change the value to this and this value to this, both are same. Clear? Both are same. So this is what about the circle. So these are very easy to play with. Now we have a few more guys. Surface also. Don't play with the vectors and planes. Only surface. Surface again. There are a lot. There are a lot. This is a very important concept. Okay, when play with surfaces. Okay, so surface dot thicken. How do you exactly, if you have a surface, how to add the thickness to it? How to add the thickness to it? So that is what the surface. Okay, well, surface dot normal at parameter. We are going to play with this UVs later, because we are going to play with surfaces also later. I mean, what do you mean by U and what do you mean by V? What do you mean by U and what do you mean by V? UV values. We just played ISO direction. Get ISO direction U and V. Okay, even you can play the same. Tangent parameter. We'll see the surface on the next day. I'll show you. Not now. Polar surface I'll show you later. Edges I'll show you later. Faces I'll show you later. So you start playing with spheres. Now we have a very few. Sphere dot by 4 points and sphere dot radius, sphere dot by best fit. So why I'm showing you all together at the same time? Because if I ask you to sit and do some sort of an R&D and find out what are the nodes that you have in the sphere, I'm damn sure you will definitely not do that. You definitely don't go through with it. That's why I'm opening all the like spheres and cylinders and cones and everything. Okay, just sphere dot radius. If you have a sphere, it will get the radius of it. So sphere by, yep, center point radius. So I have a center point and I know the radius. So it will create a sphere by best fit. So if you connect the points to it, like how we created a circle by best fit. So when you connect the points to it, it will create the sphere. Well, sphere dot center point. So it gets the center points of the solid. Okay. Well, sphere by 4 points. Same like circle. Same like rectangle. Okay. Cylinder. Cylinder. We have again few nodes only. So these are not the nodes actually. These are like we are getting an inquiry nodes. So if I have a cylinder, what is the radius? I have a cylinder with me. What is the radius? I have a cylinder. What is the height? I have a cylinder. Where is the axis? That's it. So cylinder by radius height by point radius. So to create a cylinder, I want to know the start point. I want to know the start point and I want to know the end point of it, and I want to know the radius also. The radius also. Start point, end point, and the radius of it. That's it. So cylinder using coordinate systems, and the radius and the height. Coordinate system, instead of like a start point and end point, like we are using the coordinate systems. That's it. Okay, well, let me close this. What about the cone? So cone dot by point radius. So this is always the first one. So start point, so start point, end point, and the start radius. So what about the start radius here? Here it is expecting only one radius. So it is always would be the basement. So the base. Okay, it's a base always. Okay. So this is a start radius. And the other end we don't have any. Like we have one more cone dot by point radius. So if I said the start radius and the end radius, both are 1 and 1. If I said 0.5, so we have a start radius at 0.5 and end radius it's 1 again. So almost same. If I set it to 0, 0 point, at least 0.5. Now I can see the same exactly like this. Let me connect this to this. I can see the same. I can see the same. Both are same. But you have an additional control to control the end radius, start radius and end radius. That's why cone dot by points radii. Okay. So cone dot by coordinate system height radius, you can cone by end radius. What is the cone height? What is the end point of the cone? Where is what is the ratio? What's the start radius? That's it. These are the creation nodes, all by, all by nodes. Okay, let me save this. Yeah, helix. You must have to play with this kind of a helix nodes. Helix by axis. Helix by axis. Guys, try to play with the helix because you most probably will be getting like these kind of a helix in everywhere. Okay, because once you start with, so once you start playing with a helix, okay, by axis, you will come to know like a lot of ranges and sequence. You'll be playing with a better. I'll explain this helix. Not you don't play with it. I'll explain you. So helix, I think it's only to you. I can hear. What's it? What happened? What happened, guys? Can't hear anything now. Is it on? Okay. Okay. I'm sorry. Manish, you clear now? Maybe audio. Okay. So we'll be playing with this helix and what about this convex hull? This is also somewhat important. Like when I connect the points to it, I'll show you this. This is also important. And okay, so all in one bounding box. Color, assign the geometric colors to it. So what are the nodes we have that we can set the colors to the solids? Why we have only one? Why we have only one? We have a lot actually. Wrong. Okay, then a dangerous one. Coordinate system. Coordinate system.dvn file. See, it's not that easy playing with a coordination. I mean, like a coordinate system. You have to pay some time. Okay, while we're playing with the surfaces and like see, there are coordinate system dot inverse, coordinate system dot scale, coordinate system dot rotate, coordinate system translate. You can translate the coordinate system into the particular directions. So coordinate system dot rotate, not only the geometry dot translate, connecting the coordinate systems to this, and don't play with not only that, you can play with a lot here. So coordinate system dot translate and Okay, this is the one. We'll see this later, not now.
Which node you use to transform coordinates to the shared coordinates? As I know, Dynamo understand only the project origin and project coordinate system. I mean, but to translate to the shared coordinates, you use some node, right? Transform node. Which node you use, Rajesh?
Coordinate system. No, first you have to get the coordinate system and you have to store it somewhere, Manish. You understand? So by origin will not work when you're working on projects. These are
Yeah.
like to make you understand. Okay, always the coordinate system takes by origin. If you don't want this by origin, if you want any, like if you already have any shade coordinates, you have to use the shade coordinates somewhere in your project itself. Okay, for example, if
Yes, yes.
then you will be connecting
Yes.
you will be connecting that coordinates. Let me show you that.
Yeah, in projects, all our projects are on shared coordinates only. But when you use this Dynamo script and you want to place, let's say you want to place families on the shared coordinates, so you will have to, use one node to transform the
This one,
origin to the shared, right? So that,
this one,
yeah,
this one.
okay.
So this coordinate system and this is a coordinate system. So you have to use this coordinate system always. For example, this is the finalized one. So what is the actual coordinate system? What is the actual coordinate system? You have to connect that to this. And what is the this is a Dynamo one and this is yours. You understand? So you will be getting the actual real coordinate system. I'll show you this, don't
Mhm.
worry. I'll show you this, don't worry. Okay.
Okay.
So then
Yeah.
always whenever you start playing, if it is asking any coordinate system, you have to take from here only. Clear? I'll show you, I'll explain you. This is not that easiest topic like your
What are the inputs to coordinate system in CS? I mean, you
same.
give them
I'll show
values
you, I'll show you.
directly, or how do you?
I'll
Yeah.
create it and I'll show you.
Okay.
So before we getting into the coordinate system, we have to understand planes and vectors also, Manish. Don't worry, I'll explain you. Okay. So we're going to play with this. Coordinate system is really, really headache. Even vectors. Planes are very easy. We can easily understand the planes, but not the vectors and not the coordinate systems. Okay. Well, I'll explain you this. I do understand your what do you say? Your problem. Okay, so what are other notes we have here? Let me drag all this because we cannot finish in 5 to 10 minutes that entire concept. Okay, so data dot import excel, and I'm gonna give you okay, I'll do one thing. Let me check with this. Okay, let me finish this first. Is that fine with you? I mean, if you extend the session for like 10-15 minutes, huh? Does everyone have
I
any
will
issue?
have to. I'll have to leave for another meeting.
Mm-hmm.
Not sure about others. If the others are interested, maybe you can extend.
What about you
Guys,
guys?
let Rajiv know. Yeah.
Is that
Yeah,
fine?
hi Raj. I have also another scheduled meeting after that. Yeah.
Mm-hmm.
I
Maybe we
can
can.
manage.
Maybe Rajesh, it is good to continue in the next session. Maybe
No
because
problem.
people have urgent and important calls. Yeah.
Definitely. Okay, fine then. Fine then. We'll continue in the next thing. Next thing then. Because like we have a lot to play with here, like cuboids. I think this is one. I have set all the notes in one single script itself. If you want me to share, I'll share this. Okay, but it'll take some time to open the script, and you don't need to find here and there. So if there are if you want to play with the points, so you can directly fit some notes from that particular blocks itself. Okay. Well,
And Rajesh, you said you will share the Excel file for the notes.
design script, right?
Design script, yeah.
Remind me. Thanks, Dinesh. I'll share you. Okay, I'll share you that. So date times, ellipse,
Okay.
file system, mesh, polygon, UV. UV again is a very important thing. Playing with the UV. Okay, UV dot by coordinates. What is a UV dot U? What is a UV dot V? Okay, mostly if you want to play with UVs, we have an external nodes only. I haven't shown this here. We'll see all this on XT. Vertex, war noise. Okay, fine. So these are fine. Now let's get into the actual thing. I don't see that. How many of you seen that book that I shared you?
Yeah, I have. It is actually very good.
Very good, even I like it.
Yeah.
Dynamo cheat sheet.
Rajesh, just one doubt. This classroom access is a lifetime access which you have shared, right?
Yeah, it's a
It,
lifetime
it won't
access.
be like after these sessions you'll disconnect.
No, no,
It
no.
will be there.
No, no, it
Okay,
would be there.
good,
It would be there. Okay, in case
good,
if you
good.
lost it, not a problem. Uh, we will be. I mean, if you notice that it lost because of due to space, no, we have a lot of paid space, so don't worry. In case if you lost, if you remind me, then I'll add it. I'll create a new classroom, or else I'll keep all this into a different cloud server. Clear? Clear?
Sure.
Generally not. Generally not. Till date, like we haven't uh, deleted any previous videos sharing, shared videos or nothing. So nothing to worry. Okay, get XYZ points, line by start and end points. So like curves dot get start and end points. So this is fine. So we played with this. We played with this curve offset default directory. Here it works because that's a line and we have only 2 points. We have a 2 points and the curve dot offset will work. Okay, but most of the cases, no. We'll see the translations later. I mean, in the next sessions, like we have a 2 more sessions to finish the complete geometry, and we are going to play with some sort of an examples as well. Geometry types and hierarchy. As I expected that I can finish this everything in 2 sessions, but no, there would be a change. So on 23rd, again we are going to play with some sort of a geometry types and hierarchy, and the 25th we're going to play with the translations and transformations, and on 28th we are going to play with placing the families like adaptive families or else like a general families. So that day we are going to use the entire terminology, and we are we are playing with we are going to create some adaptive components, adaptive families, and how to, for example, you have a point and you have a point and you have a point. So we have an adaptive component. So we have an adaptive component with a different set of a shape, and how to create these points. If you have a 3 points here, you have a 3 points in the dynamo, you need a 3 point set. You need a 3 point set. How to create the 3 point set? How do you create a 3 point set? How do you create a 4 point set? So this 4 points should be like this. The 3 points should be like this, or else the 3 points should be like this, whatever it is. So we are going to create an adaptive components, adaptive families. Then we will be using those adaptive components on it. Clear? Clear? So wherever, for example, I have one more point here. And how do we do that? Like paneling system. We generally call it as a paneling. We'll see that later. We haven't played with the surfaces even. So once you start playing with the surfaces, we are going to see that in detail later on. So Manish, 20, you there? Yeah. So today's 21st and 23rd also we are going to play with the same geometry concepts, and then 23rd geometry concepts, concepts again. The rest of the concepts like where we left, like surfaces, polysurfaces, and solids and everything. Okay, so once we're done with that, on the same day itself, like we are going to use, like we have seen, like how to convert the points into the lines and curves, okay, and curves to the surfaces we are going to see on the next session, and surfaces to the solids. Then at the same time, on the same session, like the 23rd session, like we are going to see how to get the surfaces from the solids. If you have a solid element, how do you get the surfaces from it? So once you have a surfaces, how to get the curves from it? I mean edges. If you have a curves, or if you have a like, then how do you get the points from it? Like vertices or something else. So this is the a positive. I mean, there's a clockwise structure and there's a reverse structure. It's a reverse structure. So points, lines, curves, solids. If I show you this, from the point line to the planes, and planes to the, I mean like a surface to the solids. Again, how do you come back to the surface to the planes? I mean surface to the lines to the points. So we are going to see that in a next session. And then 24th translations, and we are going to play with the what do you say, what is that, vectors, coordinate systems, and that's it. Transforms. That's it. It's on 20, not 24th. It's not. It's 25th. Okay, and 28th we are going to see the family placements. Clear? On 28th. That's it. That's it for this month. Okay, in the March we'll start playing with some sort of an examples again. Clear, guys. And one more,
Okay.
Manish, you there?
Yeah.
Manish, I need your
Yeah, I'll
examples.
have
Like,
to leave actually. I'm
fine,
keeping people on hold.
fine,
Yeah, yeah. Tell me if it is just a 1 minute thing.
I need, if you are using any, I already asked you in the last session also, if you're using any like a families, like point based or like any adaptive based families. So if you can share me, I
Sure.
can prepare the scripts like instead of wasting a training time. Otherwise, of course, if you want me to do that, I can do it in
Sure.
a session also. That is much better if you could share me. Okay, just share me.
Yeah.
I'll keep it for reference, and this would be confidential. Nothing. Um, I mean, we won't
Okay.
disclose it to anyone. We are very, uh, very clean on this confidential things. Okay, don't worry. Clear.
Sure.
So if you
Sure.
could
Sure.
share me, that
Yeah.
helps you, because like we are using a live project things. No, clear.
Yeah.
Generally,
Yeah.
the training should not be on the live project, but let's see how it's going to be. Clear?
Yeah. Sure.
Clear?
Okay. Bye.
Okay. Bye, everyone.
Thank you.
Thank
Bye.
you.
Bye.
Bye bye.
Plane from Kumar.